Welcome to week 2 of cryptography and data security. We're going to be moving into talking about some general, some general standards that occur today. Specifically, we're going to talk about DES, which is Data Encryption Standard, and AES, which is the Advanced Encryption Standard. And we're going to look at the difference of how they work. And we're going to look at different modes in helping us to encrypt long messages versus short messages, and which modes are safe and which ones basically reveal patterns. And whenever we can reveal a pattern, that's not good because that gives the hacker a heads up into once they see two patterns together, then as long as they get one, okay, they'll be able to get anything that matches that particular pattern. So in talking about ciphers, okay, we're going to be talking about streaming ciphers and block ciphers. A block cipher works like a paper shredder. That means it shreds a fixed size chunks. You'll get a stack of papers, you'll put them through the threader, the shredder, and then from getting it to the shredder, it will do a bulk of pieces at a time. So that's a block. The block size can change depending on how fast you want the shredding to take place. But remember that a block is just doing a piece. That's all. I mean, it's not doing anything similar to what we're doing for a stream. Now, a stream, how it's different from a block cipher is the stream is continuous. Think of that as far as the block, you had a stack of photos, okay? And so you were basically taking those photos and you say you were encrypting them. So you're basically doing a stack at a time. With continuous, it's more like a movie that you have continuous flow of information, okay? And as that information is coming through, you're taking that information and you're basically ciphering it. So that's the difference between a block cipher and a stream cipher. Instead, for example, video streaming, voice calls, real-time communications. Okay, those are the kind of the things that that differentiate one from the other. Okay, which ones you should use? Okay, use block ciphers when data is stored. Okay, it's in a file somewhere, and that it has a fixed number of bytes. You can process it in chunks. You need a strong standard for security. You use stream ciphers when you can't afford delays. Data arrives continuously. Okay, it's no block, and you want lightweight encryption. The modern systems actually take block cipher like AES, so you can basically simulate, even though you may not have a AES cipher, you can use the various modes that are available to you to kind of simulate or act like you were using an AES cipher rather than the DES cipher. Here we talk about run it in a mode that makes it behave like a string cipher. We're going to talk about those modes here shortly. Okay, DES Advanced Encryption, AES Data Encryption, AES Advanced Encryption. DES is the old standard. Things used to be basically encrypted with DES. It became obsolete. But when it was actually used, it had features like a 56-bit key or a 64-bit key, multiple rounds of scrambling. So when you say multiple rounds, I'll take some data, I'll encrypt it, okay, and then I'll take that encrypted data and I'll encrypt it. And so we have multiple levels of encryption that you might use with a DES, okay. And always keep in mind, I think we have a note here. It says, the bigger the key, in this case, it's about 56 bits versus 64 bits, then the harder it's going to be for someone to basically break that encryption in order to get to the information. Okay, today's computers are so fast that DES can be cracked in hours, okay. Many of these encryption standards were used manually. or at the time, DES was probably the gold standard until computers came around and was able to process data and analyze that data so quickly that it became useless. The AES, the modern standard, that's what we basically use today. AES is the lock is safe, strong, fast, trustworthy. Uh, you'll find AES, when you think about the Wi-Fi, when you have information that you're going over your network, in your home network and going through your Wi-Fi, how that information is encrypted. So this is basically using an AES standard. Banking applications, HTTPS websites, encrypted storage. The keys, when we compare it to the DES, okay, now we're talking about 128-bit keys, 192-bit keys, and 256-bit keys. The keys have become much larger with AES. AES scrambles data through several rounds, just like the DES does, each adding more confusion and complexity. That's what you want to do. You want to make it difficult and painful for a hacker to get the information and basically decrypt that information. Okay, DES versus AES. Think of DES as a small padlock, okay? And think of DES as a giant high security lock, okay? And again, DES is basically not used anymore, okay? Key size, small, weak. AES has a large key, mixed and strong. Age is old. AES is modern. Used today, not secure. It's not considered. If I used a DES encryption standard, it wouldn't be considered that I'm basically putting something in place that is secure. Modes of operation. Okay, modes of operation. Why do they matter? A block cipher like AES only scrambles one block at a time. But we need to encrypt whole files and emails and videos. Okay, so modes are basically operation types that we can go through. They are basically the rules that tells the encryption standard how to handle long messages safely. And here's four that are basically used today. ECB, Electronic Cookbook, CBC, Cipher Block Chaining, CFB, Cipher Feedback, and then CTR, which is Cipher Counting. Okay, what does the ECB look like? Okay, Electric Code Book is a block cipher mode where each block of plain text is encrypted independently using the same key. Okay, so I have 100 blocks of data. I'm going to use the same key in order to encrypt those 100 blocks of data. Okay, that's the Electronic Cookbook. It is the simplest of all of the different methods, but it has one major problem. If I have two blocks that basically look the same, then they're going to give me the same cipher when it comes out. That's not good, okay? To be able to have two blocks that are the same and both of those blocks are basically encrypted to give the same output. This is what we call pattern leaking, okay? Remember, we said that once we get a block, okay, and we can take that information, we encrypt it, we get another block, and it just happens to look exactly like the first block. We encrypt it, we get the same thing. Okay, that in itself, that's a leak. That's a pattern leak. And once I find one little thing in one of the patterns, okay, I can just apply that to the other patterns that I've encrypted that use that same key. So it's not good. Example here given, if you encrypt using ECB, you can still see the outline of the picture, even though you might have encrypted all the colors. Okay, ECB, never really used for real security. Now, cyber block security is a little different. It basically takes a block mode where each plain text block is combined with the previous ciphertext block. So I have block 1, block 2, block 3, block 4. Okay, when I basically create the cipher for those things, I'm going to take block 1, I'm going to combine it with block 2, and then I'm going to basically encrypt it. Okay, once I encrypt it, okay, I'm going to be taking that block, which is block 1 and 2. When I'm ready to encrypt block 3, I'm going to put all of those 3 blocks together. I'm going to encrypt it. So the more blocks we have, basically we're going to be combining those blocks one by one to connect to each other. So in reality, even though I might have two blocks that are the same, being that there's probably going to be a different sequence, I'm going to get a different answer from my encryption. CBC, cipher block chaining. Cipher block chaining is a block cipher mode where each plain text block is combined with the previous ciphertext block. Okay. And that's basically what we just went over. This means no patterns. Data repeats, the ciphertext doesn't repeat, but it has a downside. Must process blocks in order. Okay, one error can damage two blocks. Since I'm combining block 1 and block 2, if I have an error in block 2, my resulting encryption is going to be bad. Yeah, so that's one of the bad things, in that any kind of errors I have in data is going to carry over into multiple blocks. A cipher feedback, feedback is a mode that turns a block cipher into a stream-like cipher. Okay. Cipher feedback lets AES behave like a stream cipher. It works like this. AES produces a stream. You XOR, okay, the stream with your data. Okay, this is a useful data that comes with small pieces, like live communication. Downside, errors are spread for a short time until the system catches up. I want you to do some research, okay? I want you to do some research and be looking at what does it mean until the system catches up, okay? So do some research for me in that term here, error spread on a short time until the system catches up, okay? Okay, CRT is the counter mode. Counter mode is where the block cipher encrypts a counter value and then results combined with the plain text. So what I'm encrypting here is basically a counter. I'm taking that counter and I'm combining it with the plain text. One thing that I didn't specify here was the XOR. We'll kind of cover that in class on how that process works. We're basically taking bits, and with those bits doing an OR on it. So if I have the plain text has bit 1 and the key has bit 1, then my result is 1. If I have 1 for the plain text, I have 0 for the key, then my result is 0. Okay, so we'll kind of talk about that, the XOR. It's basic, your math. Basically a way in math that we basically process bit information in order to basically to basically to make sure that the encryption happens at the bit level and that everything works correctly from that. So here again, the counter, I encrypt the counter, I combine it with the plain text. It's one of the most popular counters today, popular modes today. Instead of chaining blocks, CRT chains the counter. Emphasis on counter with AES. I do the XOR. We'll talk about that in class. Increase the counter, okay, and then repeat. So basically, just go through this process where we're really not encrypting the whole blocks of data, but we're basically taking the key, doing some magic with it, and then taking that a key once I've encrypted it and apply it to the plain text. Benefits, very fast, can encrypt multiple blocks at one time, no error spreading, no pattern leaks. This is why CRT, okay, it appears in modern security systems today. And we'll talk about TLS. You're going to see a lot of acronyms, okay. We'll be going over those acronyms and basically breaking those down and what we how these particular encryption methods are being used with these various modes. Pattern errors and parallelism. 1 second. Okay, talking about patterns, errors, and parallelism. One good thing about recording is you can stop when we have interruptions. So just add one. Okay. Okay, patterns, errors, parallelism. Only ECB is really dangerous. The other ones probably can get away, even though we have the errors that we have to deal with. A summary of those errors: if one bit is damaged for ECB, only one block is damaged, which is good since I'm doing one block at a time with the same key. CBC, two blocks are damaged because remember, I'm taking block 1 and block 2, I'm combining them together, and then I'm doing my encryption. CFB, several bytes are damaged because of the way we're processing. And if we go back, you'll see, you remember that if we're talking about CFB, here the mode is we're taking a block cipher, a stream-like cipher, and basically it produces a key stream. Okay, so we're taking those blocks, create a stream out of it, and then doing an XOR. We'll talk about that again a little bit later. But here with the CFB, then several bytes are damaged because we're doing the stream. Once we combine them and we're doing a continuous, if something happens that's bad, that whole stream is considered bad because it's not a piece or a block that we're doing, but it's the whole stream we're working on. So that's why CFB has several bytes damaged based on the fact that I might have just one block that originally had an error. CRT, only one byte is damaged. Okay, with CRT. We're going to dig a little bit deeper into that and why that is, but just for right now, just remember that CTR is basic. I said CRT, sorry about that. CTR is probably the best of the modes in encryption that we have here, the 4 listed. ECB is the worst, don't use it. CTR is the best, it's the cleanest and safest for noisy environments. Which modes are fast? Here, parallelism means can I encrypt many blocks at once? If I can do 10 blocks at a time, I'm going to be quicker than I have to do block 1, then block 2, then block 3. So in sequence. So as far as parallelism, okay. ECB, yes, okay, we can do parallelism. Okay, but in this case, again, the ECB is bad, so we don't want to use it. CBC, we cannot do multiple blocks at a time. CFB, no, we cannot do multiple blocks at a time. CTR, yes, we can, and it's super fast. So this is kind of the main reason why CTR is so common. But remember, CTR, we're taking the key, we're doing the encryption there, and then taking that and apply it to plain text. You will have detailed touch points on this with your project. Remember, each week we're going to have additional items to the project that you'll be working on. We will be talking about parallelism and the various modes and blocks and streams and where we're going to use it and how it's going to apply to your particular project. So look for that. Look for the specifications for your particular project for week 2. And we'll delve in more some practical applications of using the modes. So in summary, today we learned stream ciphers is encryption bit by bit for a stream of data. Block ciphers encrypt chunk by chunk. DES is old and broken. AES is modern and secure. ECB is unsafe, but the other 3 are varying levels of safety depending what you're probably doing it and whether you have errors involved that you have to worry about. Biggest idea to remember: modes of operation control how we safely use AES. Okay, so based on the modes that we're talking about here, the ECB, CBC, CFB, and CTR, depending on which one we're using, that is going to tell us how safe our particular encryption mode is. Okay, that's it for week 2. You have your homework assignments, your quizzes, and for some of you, your discussion boards. So good luck, and we'll see you either in class, okay, here in a few days, or we'll see you next week when we talk about week 3. Okay, have a good one. Bye.